We got Arjun speaking from Connext and York from Hyperlane. And this space is we're going to shoot for a half hour. The space is going to be on xERC20, and we're going to talk bridges, cross-chain tokens, and a new token standard. So maybe we can kick it off with speakers, and maybe you can introduce yourself and a quick bit about your projects.
Hyperlane's an interoperability protocol that's been operating on about 12 EVM networks for the past year or so, and we're now expanding to other ecosystems since we've kind of seen some traction with some of our abstractions, mostly focused on kind of modularity. So allowing application developers who want to bridge or send arbitrary messages to encode and configure their own security preferences. And yeah, I'll hand it to Arjun.
Awesome. Thanks, York. I'm Arjun. I'm one of the founders of Connext. Connext is also an interoperability protocol. Connext has largely been focused around trying to, operates in a very similar space to Hyperlane. We want to help projects build applications that can exist on multiple chains at the same time, and ideally in a way where users don't ever really need to know or care that they're interacting with multiple chains. And we think that this is actually the only sustainable outcome as we head towards a world with many, many more chains and rollups in the future. Connext, although Connext and Hyperlane are quite similar in like the specific problem that we're trying to solve, we kind of target like two slightly different parts of the stack. Connext specifically focuses on a couple of things that a lot of the other bridge projects don't really do. The first is at the kind of like messaging layer. We have an approach where we try to not be responsible for security as much as possible, because we believe that there are better kind of established best practices for how to securely send messages between chains that are already out there. So for example, when you're sending a message or funds from Ethereum to Arbitrum, the safest possible way to do that is the Arbitrum rollup bridge. And so for all interactions that happen that involve Arbitrum in Connext, those interactions are actually secured by the Arbitrum rollup bridge itself. And we use we basically use fault proofs and Ethereum layer 1 data availability to make sure that data that is available on a rollup, or I guess like some interaction that happens on a rollup, can then be transported to all other rollups within a certain time period, using the rollup bridges themselves and using Ethereum. Secondly, and this is the other piece that kind of sits on top, is we build a mechanism for what we call and have been calling for a while fast execution, which means we have an off-chain network of actors where while a given message is going through the rollup bridges in the background, which takes like at least a couple of hours, we have an off-chain network of actors that actually immediately executes the transaction on the destination chain. Sometimes involving funds and sometimes not. And usually that interaction happens within like 30 seconds for the rollups to up to like a minute and a half for, or like 2 minutes for chains like Polygon that have like higher reorg risk. And those two things kind of come together to give you a very like seamless experience as a user, where you don't really need to know that all this is happening in the background, but where we opt into kind of the best security that we can for any given ecosystem. And in ecosystems where there isn't already a canonical bridge, we can plug into other systems, things like Hyperlane that have more like configurable security properties, to be able to expand to chains like further out than just like the Ethereum rollup ecosystem. So yeah, I'll pause there. There's a lot of information. Apologies for that. But yeah, I'll pause there.
No, all good, all good. That was great. Thank you guys. So I actually want to start off actually unpacking part of what you said around the different kind of functions of a bridge. Actually, I think that could be a good way to start. I mean, people who are in the modular and kind of like roll-up ecosystem, I feel like those functions have been the functions of a modular blockchain have been hammered on a lot, and I think people have a better mental model as with the current state today than they do of the core functions of like bridges and messaging parts of the system. So you kind of touched on it a little bit, and I know you touched on it in the the post about ERC20, which will xERC20, which we'll get into. But I want to see both of your perspectives on like what are the core, just unpack the core like functions of how these chains or rollups interact with each other, and maybe maybe you can kind of both give your perspectives.
Yeah, I can.
Go ahead. Go ahead, York. Actually,
Sorry. Cool. Yeah, I can give Hyperlane's kind of perspective on this, and then excited to hear Connext's as well. So I think like Arjun noted, the kind of core product that interoperability protocols are providing is an on-chain API for developers to pass arbitrary bytes between different blockchains in a way that's trust minimized. So, that's kind of a very generalized communication protocol, and one of the kind of like most common application that's built on top of those protocols is token bridging, which I think probably the whole audience is familiar with. In those cases, the message content is basically kind of like an amount of token that was either locked or burned on the origin chain, and a recipient address for that token to be minted to or unlocked on the destination chain. And kind of the way in which the content of those messages are verified really depends on, like Arjun noted, kind of the pair of chains that you're working with, what the verification requirements should be. And so, if you're going from Ethereum to Optimism or Arbitrum, probably the best verification mechanism is to use the quote unquote native bridge, which has fraud proofs that are implemented and maintained by the core teams that are operating those chains. But as you want to do interoperability between chains which maybe don't have such a close relationship, like a rollup settling to Ethereum, you have to come up with kind of solutions for pairs of chains which maybe don't have some like kind of community established, or maybe don't have a fraud proof system yet. Maybe there is no light client implementation for, let's say, verifying like the Ethereum consensus on a Solana chain or on a Cosmos chain. And so that's kind of where I think a lot of the debate is in interoperability, is like, what should the verification requirements be for this matrix of different chains? And I don't think really anyone has like, and there's not really a kind of widely accepted standard for a lot of these pairs of chains. And so that's kind of the trade-off space that a lot of us are playing around in. And there's a lot of kind of excitement about like cross L2 messaging that I know Connext has been focused a lot on, which does allow you to maintain kind of strong security guarantees due to the presence of fraud proofs on the L1. So I'll pass it to Arjun.
that was a great like explanation. I guess like so at a high level, like the way that we see bridging in general, and by this I mean like messaging bridges, though liquidity and like token bridging is just like an application of this. So you just build like a token bridge contract on top of this, and we can get into that with the xERC20 discussion. But the way that we see this kind of working, or the way that we see the stack kind of looking, is that there's really three pieces to a messaging bridge. There's the base layer transport, which is how you get data from like some blob of data from one chain to another. And that in Ethereum land involves like, it's usually like a simple task of relaying that data. But in other ecosystems, like in, for example, Cosmos, you have IBC, some like the IBC transport authentication and ordering spec, which is like a full specification for transport where you have chains like connecting to each other at the P2P layer. So like they're actually like connecting to each other's ports and stuff like that, which is a much more intensive like connection paradigm, much more lower level. And of course, this like needs to change depending on like the structure of the chain that you're on. So it's an open problem to find a transport layer that works everywhere, but it's not one that a lot of projects are focused on at the moment because there isn't as much value capture at the transport layer. And in my opinion, I think it's just best to work towards something that is like, pure kind of open public goods for this because it'll just broadly help the space. Above transport is like York was starting to kind of really get into, which is awesome, is this verification layer, the security layer. And this is the piece that has sort of been the like open question for bridging for a very long time, because this is really where like all of the risk of bridging comes from. And the risks here come from a couple of things. The first is like the implementation of the security mechanism itself, which if it's like not implemented correctly or potentially has like vulnerabilities, can get hacked, and then that can lead to really catastrophic effects for a bridge. But then the second is the trust model of the security mechanism. So by that we mean like who is actually verifying this thing, right? So like a really simple implementation, but with a terrible trust model would be like a fully custodial system. So there's like someone is just running a server, kind of like what was happening with multi-chain, where someone is basically just running a server and that server is just doing everything. That is actually simple enough that it's like less likely to get hacked. But then the flip side of that, of course, is that one person now controls the entire network and can rug everybody's funds unilaterally. And then the other end of the spectrum is, how do you get to like the most kind of secure options, most trust minimized options? Well, that, as York touched on, like that is really dependent on the chain. So like for rollups, it'll be, the rollup bridges and like shared sequencing for like L1 to L1 communication will be like ZK-like client-based stuff. For Cosmos, it'll be like the IBC-like client spec, et cetera. And so there's this like more complex problem of like, how do you make sure that you plug in the right kind of verification mechanism for every set of chains that you're interacting with? And in addition to plugging in the right kind of verification mechanism, make sure that you're actually using a bunch of different options, because, there's a risk, especially with like, ZK-like client-based stuff, that like, if it's not implemented perfectly, it could get hacked. ZK is very, very difficult to audit. And, it's like obviously a concern that this stuff is still quite immature. So there's a big kind of hairy open problem space around security that, at least from my perspective, is like still fair game. There's a couple of approaches that I think are really interesting. I think for me, the approach that makes the most sense is kind of what Hyperlane MMA, which is like multi-message aggregation that was proposed in the Uniswap forum, and Hashi, which is like the aggregation header aggregation protocol that is being built for Gnosis Chain. From my perspective, those three approaches are really quite similar, and they are likely going to look like what this space ultimately looks like, where you'll have like a marketplace effectively of a bunch of different options, where like security providers, like light client providers, or other chains, or like shared sequencers can come and just plug in, and then they can earn a share of fees for providing security. And then lastly, there's the kind of top layer, which is the one that I mentioned about Connext, which is what we call execution. And really that layer is, after you have some data that's gone from one chain to another and it's secure, most of the time you're not actually sending raw data because there's just a lot of it. You can't, it's too expensive to try to do security for every single message that gets through a system. And so most of the time what you're doing is sending around like a Merkle root or a block header or something like that, some sort of compressed format for the data. And so the execution layer really does two things. It provides the data from off-chain needed to actually do something with that header or Merkle root, and it creates a proof to do that. And in special cases, like I mentioned with Connext, it potentially does things like fast execution, where it just immediately executes a transaction on the destination chain. And like you have off-chain actors that front money or have some stake to do this, and then they get repaid by the protocol later. So that's a way to like speed up the experience for users, even if the backend stuff takes a little while to figure out. That's kind of at a high level how we think about bridging, but then also generally what we've seen most other projects independently talk about as well. The words that are used to refer to these three layers are sometimes slightly different, but generally speaking, it seems like everybody's kind of independently coalesced on the same mental model, which is a really, really promising thing.
Awesome. Yeah, no, I think that's right. They all start to seem pretty similar, even if using different words. And I think it's good that we can agree that the components. Everyone agree. If people kind of agree on the components, that's a good thing. I think the reason I wanted to have you guys unpack that is because I feel like a lot of people don't currently think about like separate almost like the general messaging part from like the token and assets as like an application on that kind of like messaging system. So I think that's a helpful foundation. Let's
Yeah, it's like a good
dive.
way to think about it is like, it's like if I run an OP stack rollup right now, like I can decide I wanna create a rollup that's a payment network, right? I can decide that what all that rollup is going to do is build really efficient mechanisms to pay people that are on the rollup. But fundamentally, the rollup itself, the EVM compatible OP stack rollup, is actually more general, right? It's doing any kind of thing. And the payment pieces are like an application, basically contracts that you write on top of that rollup to do the thing. It's the same mental model
Right.
here. Like every liquidity bridge, every token bridge is an application and is like a specific instance of this more general thing, which is messaging. And messaging has to exist. There's no like way around it. That is something that like every project ends up either building or using something else for.
Right. Yep. No, that's really helpful. And that actually kind of brings up one kind of question around, like what do these like messaging systems look like from, the canonical, like if you take a canonical bridge, like what does can other people build on like these arbitrary messaging systems? Like what people I don't think have a good mental model around this stuff. So which we'll get to, I know when we talk a little bit more about the standard. But let's actually quickly talk about the general state of cross-chain tokens specifically. So if we hone in on that application, um, like what is the current status? What are the options today for token issuers? And what are some of the trade-offs involved? We can start with either.
Yeah, I can hop in quickly. So like I mentioned before, there's kind of two models for the token bridging application. One of which is this lock and mint, burn and unlock model, where you have basically like some token, let's say it's on Ethereum, and you want to bring it to Optimism. So you deposit it into the Optimism bridge. That token is now basically escrowed as like a collateral on the bridge on Ethereum. And on Optimism, that kind of balance is minted to whoever you specified as the recipient of your deposit. And when someone wants to send their token back to Ethereum, they basically have to burn it on Optimism, and the underlying collateral will get unlocked and sent to the corresponding recipient on L1. So that's one model. The alternative model is, I guess, just like a more native mint and burn approach, where instead of collateralizing a token in a bridge, which sometimes functions as like a well, I'll get into the problems of the collateral system maybe later, but instead of collateralizing, you basically just burn and mint on every domain where you want your asset to be issued. And this is the approach that something like USDC is taking more recently. If anyone has seen like the Noble chain or like their USDC product, where basically you have to kind of request their off-chain kind of management of their asset issuance on a specific chain by burning some representation of USDC on a chain that they support, and then they'll be able to kind of off-chain go and mint that asset for you wherever you want it. And the trade-offs there are really around, I guess, liquidity. So obviously, like when you have the collateral sitting in a token bridge, it's not doing something else. And so with USDC, kind of the unspoken kind of agreement, I guess, or relationship is that off-chain Circle is putting that USDC that's not issued to work, whether that's through some sort of like treasury bond system or however they're managing that off-chain. And obviously the trust model that comes with that really relies on trust in that asset issuer to basically be managing their off-chain books appropriately, and it becomes difficult to have auditability. That's kind of like I think quite a controversial, I guess, trade-off that USDC has made. And yeah, I think the other problem is when you have these token bridges, which are using this like lock, mint, burn, unlock semantic, each kind of path that you take with those bridged tokens needs to be unwound at some point. So if you want to go from like Ethereum to Optimism, and then Optimism to, let's say, Arbitrum using some other fast liquidity network like Connext, the collateral associated with that token is still like locked up in the Optimism bridge. And so that position basically needs to be unwound. And I think that's what Arjun's referring to as like kind of the people who are taking the upfront, like posting the upfront capital in this fast liquidity network, and then basically being repaid once the Optimism bridge position has been unwound. But yeah, that's really like kind of a capital efficiency trade-off that I think projects like Connext and Across and some of these other ones are closer to. So I'll let them speak on that.
Yeah, I mean, there's basically two core things, right? There's two problems associated with bridging a token. There is bringing a representation of a token to another chain, and then there is giving users a good experience with, bridging their tokens in like a consumer interface, bridging their tokens between chains. And those are two separate problems with two totally separate solutions. So if you have a totally new layer one that doesn't have any bridges connected to it, the first problem that you'll actually run into before anything else is like, if I say I want to create a lending market that allows me to borrow like my native token of my chain, XYZ chain, it allows me to borrow XYZ against USDC. In order to even create that lending market, the first problem that you're going to run into is just, how do I even get USDC on my chain? And so to do that, you have to go and figure out some way to get a representation of USDC created on your chain. Now, of course, Circle can come and mint their own representation because they're doing that now. But I mean, let's say that they're not doing that, or let's say that you're a tiny chain and it's really difficult to make that happen. The first kind of problem that you're going to run into is you will have to go and figure out, either I need to build my own bridge between Ethereum, usually, depending on which ecosystem you're in. But if you're an EVM land, then Ethereum. You'll either have to build your own bridge from Ethereum to your chain, or you'll have to go and work with some like third-party bridge providers. Now, there's a trade-off space that exists here, which is if you build your own bridge to your chain, now you are responsible for the security of it. You have to really think carefully about how to do that. If you decide you want to be a rollup and have a rollup bridge, then that's obviously the best possible security. But then the trade-off is that bridging back, at least for the optimistic rollups, takes time. And even with the ZK rollups, I think right now it's still like a while for safety reasons. And then the flip side is, if you decide you want to actually be like a totally independent chain that isn't a rollup or anything like that, for whatever reason, and you decide you want to go with multiple bridges, now you have the other end of the spectrum, which is you do still have a security risk that comes from these different bridges, but at least it's not all concentrated in a single bridge. The flip side of that, though, is now each bridge is going to mint a different token because each bridge has their own independent system for how they mint tokens, and those systems are not compatible with one another at all. Even though the tokens themselves are the same ERC20 tokens, the systems that mint them and the ownership of minting rights of those tokens are not actually the same. So then that's how you end up, getting to the situation that so many chains have gotten into where they're just like, okay, I wanted to get USDC to my chain, and now I've ended up in the worst outcome where I now have any USDC, AXL USDC, OUSDC, Seller USDC, Next USDC, whatever. And you end up with 20 different implementations of USDC, and now users have no idea how to even go about building that lending protocol because they don't know which USDC to use. So that's kind of the first problem space, which is how do you even get a token to a given chain in the first place? Now, obviously, the ideal outcome is that you basically just have a single canonical bridge. That single canonical bridge mints a single canonical token. And in most cases, what people are saying is they're willing to take the trade-off of the challenge of bridging back and forth from a given ecosystem. So in an optimistic rollup, for example, they're willing to take the trade-off of the 7-day exit because you get the security of the bridge, and also you get the fact that and everybody knows, everyone colloquially agrees, this version of the token is the right version of the token, and there's no arguments about that anymore, which is really ideal. But that now presents the second problem, which is if you're a user, how do you actually use this thing? So say now you want to go from Arbitrum to XYZ chain, or actually you just want to go from XYZ chain to Ethereum. Having to take 7 days each time to do that is obviously a giant pain. And if you want to go from Arbitrum to XYZ chain, it's even more complicated because now you have to go through Ethereum, which is itself an extremely expensive thing. So what is the solution to that? Well, the typical approach, and this is kind of how Connext works, how Across works, how Hop works, how a bunch of other basically roll-up focused liquidity, fast liquidity based bridging mechanisms were developed, is that you, on top of the minted representation of the token, so assuming this minted representation problem has been fixed, you then have these other systems do this thing where they provide liquidity for you to get into and out of this system, into and out of this rollup in the canonical asset as fast as possible. And in the background, those liquidity providers are basically the ones that are taking on the 7-day exit window if they need to, or are the ones that are in a single, in Across, for example, in a single large batch transaction, all USDC is netted off between all of the different chains and rebalanced between all of the different chains. So instead of having to pay gas costs each time, you only do it once. Now the problem is that this actually creates, so this is nice in theory, but this actually creates and it works in some cases, right? It works for USDC, it works for ETH, it works for basically tokens where people are willing to supply liquidity and pay money to supply liquidity because those tokens are transferred frequently enough that you can earn enough fees from them that it's worthwhile for the liquidity providers. But now what happens if, say, for example, you have a shitcoin ABC on your chain, and nobody really cares that much about trading it, but project ABC that has issued shitcoin ABC needs the ability to bridge shitcoin ABC between chains because they are deployed on multiple different chains, and they need ABC to actually do something very specific in their protocol. There's not enough need for it to be bridged, but there is enough need from the perspective of the actual protocol that this is something that has to exist for them. And that's where you start getting into this core problem in the trade-off space that York was mentioning around capital efficiency versus getting the right asset versus having to think about unwinding positions, et cetera. Because now you have this problem that exists in the space today, which is if you are issuing a longer tail asset, so anything that is not one of the top 4 blue chip assets, how do you get enough liquidity on enough chains to make it to make it seamless for users to transfer your tokens between those chains? And the answer to that is either you spend lots and lots of money to do it, which a lot of projects are doing, or you give up on the canonical bridges, so you give up on security, and instead you try to work with some proprietary standard, something like multi-chain or layer 0 OFTs or Axelar's ITS or whatever, right? You work with some proprietary standard that works everywhere, but doesn't actually use the canonical bridges whatsoever, and now is like fundamentally incompatible with the canonical bridges. So you can see that for a token issuer that isn't one of like a small select group of projects, there really is only one option. You're forced into a situation where like you have to work with something like multi-chain. There's no way to do anything else if you want to survive as a project. And that's the reason why, like, I mean, we talked to a ton of projects that were affected by multi-chain. Many of them knew and were like fully aware of the fact that the multi-chain security model was terrible. Everybody was kind of sketched out by them. I mean, multi-chain didn't necessarily have the like best reputation in the space either. And despite that, they were forced into working with them because there was just no other option. There was no way there was basically like locking yourself into some ecosystem had to happen. And as a result of that, they just kind of chose, okay, we'll just lock ourselves into the biggest ecosystem because what other choice exists? xERC20 gives that other choice. Like it is the solution to this problem, where instead of having this trade-off space of either you spend lots and lots of money for security, or and to make sure that you always get the right canonical asset and that you have fungibility with the canonical bridges, or you lock yourself into like some other third-party mechanism that may or may not be secure, and if it explodes, then your whole project is fucked, and there's nothing you can do about it. Instead of those two being your only choices, now you have a third option, which is you deploy this token standard. You can like map any bridge to be able to mint this token on any chain. And so you can allow like the Arbitrum rollup bridge to mint the token. You can allow Hyperlane to mint the token. You can allow Connext to mint the token. And most importantly, you can set limits for how much they can mint per period of time. So per block, there's a certain limit of tokens that accrues. And if the bridge tries to mint more than that limit, then obviously the transaction fails. And that basically means that if a hack happens, you actually know, if you're the token issuer, so if you are, project ABC issuing shitcoin ABC, you know exactly how much ABC you could lose at any given point in time, even in the worst case where any of your bridges gets hacked. And that is a fundamental change for the bridging space. This is like something that it removes the need for liquidity completely, which is good because liquidity-based bridging just doesn't scale. And it removes also this like terrible outcome where you lock into like something like multi-chain and there's no competition whatsoever and there's no way to actually improve on that.
Yeah, super well said, Arjun. I think definitely we need some sort of standard, like you mentioned, with the MMA bridge or with xERC20 that kind of allows applications ultimately to have sovereignty. I think that's the core problem here, is that bridges have become kind of these intermediaries for products. I don't like using the word shitcoin, but shitcoin ABC on if they want to if they want to provide an application to users on 10 different long tail chains, they now have to take on this counterparty risk of what basically whoever has the most liquidity on those chains, and they don't really have a choice in that matter, without kind of easily getting outcompeted for whatever product they're trying to provide. And so, the solution is definitely basically establishing a way for applications to specify a risk framework and risk tolerances across all of the different providers to prevent any single provider from becoming kind of like the central bank of a specific chain ecosystem. And those risk tolerances can evolve and can adapt as new security models become available, or as certain bridges kind of demonstrate their, I guess, incompetence or suggests maybe malfeasance. We can now tune those risk frameworks to accommodate for all these different, like this I guess higher dimensional trade-off space. And I think it's actually something that should be really assessed more formally. I don't know if there's like anyone in the DeFi space looking at kind of like more formal risk assessments of these things. But I think the problem right now is like, because these systems are so opaque oftentimes, like in the case of multi-chain or layer 0, we can't actually like we can't do algebra on these kind of risk tolerances because we don't have a number of like, hey, this is the amount of risk we have in this bridge, or this is the cost to attack this system, because it's all just like kind of reputational security and trust in kind of off-chain
Very
actors.
obfuscated.
Yeah.
Yeah. Yeah, exactly. I mean, I think one of the most like important, like one of the kind of meta benefits of this is just that the reason that we're in this situation right now, like we've been talking about bridging being broken for like 2 years now, and there are still $100+ million hacks happening. It's kind of preposterous, and it's not fundamentally. It's not just that like it's not just that the technology is immature, because we've had enough time now to mature the technology. It's just that the incentives don't exist for projects to focus on making things more secure versus just trying to find ways to like capture more market share. Like there is no right now, I mean, we try our best to do this, but at the same time, like it's really challenging because like you're basically locked into a race to the bottom competition with a bunch of other bridges where right now, like the incentives drive you towards wanting to go and capture as much token market share as possible as quickly as possible. Because once you capture a project to be a token that is in your system, they can't change. It's like very, very, very difficult for them to migrate away. And that makes it so that's just like such a powerful effect that it's like way better for you to focus almost all of your resources towards onboarding those projects as quickly as possible rather than focusing on making the underlying system actually work securely. And this, I'm a strong believer that like incentives really, really drive behavior. I think this is just a system of broken incentives. It's not anything else. The moment that we change the incentives around this, I think people's behavior will change really significantly, and you'll actually start seeing more collaboration in the bridge space in the first place. And I think that this is one like quintessential example where the meta benefit of this is that it completely rewrites the incentives. Because a token issuer can now at any point update their preferences of risk and also support on bridges at any time. You now have a requirement as a, like, if you onboard a token, you need to make sure that you're meeting a certain minimum quality of service, because they will switch away. If like tomorrow somebody invents an extremely like a new system that provides a much, much better security model than anything that's ever existed before, that now actually could get usage. Versus in the past where it's like, okay, they don't really have a pathway towards the market, which is why, for example, you have a ton of like, new like client-based bridges coming out, but they're all struggling to actually figure out how to get market traction because, how do you compete with a bunch of very, very large organizations that have been in this market for much longer and have built all the product stuff, but haven't actually focused on any of the underlying security yet? You can't. The only thing that you can then do is try to sell to them instead. So I'm personally really excited about that. I think that it's going to drive a lot of like healthy conversations and healthy competition around security in particular. And like by driving competition around security, that is how we will fix bridge security. Like where this standard won't independently make every single bridge transaction secure. It will allow you to control the downside risk of a given token bridge, or a given token that has been bridged across chains. But the thing that ultimately will make it fully trust minimized and make it so that for every single token in the space, that this is going to be as secure as possible, is just the incentives that will eventually drive all of us to start competing on security instead of anything else. At least that's the hope.
Makes sense. Yeah, I don't think anyone would argue about how messy this stuff has been so far, and I think everybody is probably excited to hear that there could be better solutions finally. So, with that said, you talked about kind of getting adoption, and obviously, when somebody hears a standard, I mean, I certainly now, whenever I hear something like this, despite the benefits of the standard or how good it is, I just think of like that meme of like, oh, we need a new standard, and then it's like 16 standards instead of 15. So, I guess my question is, this sounds really, really good. what can be done to like foster adoption of this standard? I mean, I know it's certainly great that actually I'll leave it at that and see what you guys think.
I can jump in here since we actually just got off a call talking about this. So I think there's two things that really matter here. The first is, so like I've like always hesitated to be to push for standards, because I think that I completely agree. Like people will just end up creating more standards and then it just fragments everything. I think this is a situation where there's like a meaningful difference between the like quote unquote standards that have been proposed by different projects that are their own proprietary thing, which in my opinion shouldn't count as a standard. I mean, if it's something that is like built that hard codes your own protocol in, it's not really something that's it's not really credibly neutral enough to achieve the scale that a standard would, and you're just fragmenting more. So my hope is that this thing, which is actually legitimately just tries to be, at least in the code, as much as, I mean, not tries to be, in the code is 100% credibly neutral. And then in general, as a broader idea, tries to be as credibly neutral as possible. My hope is that this is in a slightly different class. And I think the two ways that we're going to, that can get validated in the minds of token issuers, because they're ultimately the decision makers here. I think the two ways are, one, just broader education, because I think like the things that we talked about on this call in general are extremely poorly understood in this space. They are ideas that are quite complex and hard to grapple with, and they require quite a bit of like previous understanding of how blockchains work and like what rollups are and like how interoperability works and things like that. And so I think a lot of people in the Brit space have just struggled to find ways to like communicate these things clearly and educate people clearly on them without just resorting to some sort of narrative like, okay, ZK Bridge is good, right? So that's one thing, is I think education. We need to like really push this whole space forward in terms of its like collective understanding of the trade-off spaces around these things. And then the second thing, and I think this is an initiative that we've been trying to push for with a lot of different folks, is to get broader adoption amongst the bridges themselves. And by that, I mean both kind of third-party bridges like Connext and Hyperlane, and then also canonical bridges, so like the chains themselves, and get a broad coalition of different people saying like, yes, this is the right approach. We are all objectively supporting this because this just makes sense. And I think that that's how you get it out of the hands of being like, oh, this is like a standard that's proposed by like Arjun, or proposed by like one organization, or proposed by a small group of people, and away from that to being like, okay, this really has widespread support, so it must be something that is much more neutral. Yeah, not sure if you have other thoughts on that, Jörg.
Yeah, no, I totally agree. I think we've gotten to a point, I think, in the maturity of, I guess, the protocols and the products that have been operating on top of the protocols in the past couple of years, where while maybe some of these trade-off spaces are poorly understood, there is kind of people are getting smart, I guess, to the potential downside risk of just aping into whatever bridge without really assessing the underlying trust model. And I think I guess like given the state of the market and kind of like the liquidity crunch and just the emphasis on returning to fundamentals, I think this is now the perfect time for a standard like this to actually proliferate across the protocol layer, while people aren't kind of like frantically competing over product and having to cut corners. So yeah, totally kind of aligned with that vision. We definitely, at Hyperlane also have some ideas for standards, and I think definitely excited to collaborate more with teams like Connext.
Yeah, I think what we need to do is like have, yeah, I mean, it's interesting because it's like, I think this is like a manifestation of being in a space where like the funding landscape for projects in this space has changed so much since like the early like since like the 2017, 2018 era. And because the majority of projects have to like raise a ton of rounds from like VC capitals and private now, just to be able to like operate legally, because projects have to do that, it just like creates these kind of adverse incentives where like as a project, you're now like heavily incentivized to try to capture as much market share as possible versus collaborate. And it's just like, again, unfortunately, the incentives really drive a lot of behavior here. I would love to work towards a model where we have like, I think from my perspective, a world where like the entire interchain problem is solved by one project just doesn't exist. Like it's too big of a problem. This is literally the future of the internet. It's sort of like, imagine if you said like one single company was going to run the entire internet. That would be ludicrous and extremely concerning. There's a really good reason for why like the internet protocols back in like, in the 70s for like the lower level protocols, in the 90s for HTTP, there's a really good reason for why those were created by a broader coalition of like research organizations, scientists, like universities, and companies and military organizations. So it was like it wasn't just like one entity. I think we're in the same place now where the ship has sailed for any one project to be the project. I think like the way that we will get out of this and the way that we'll actually like, there is no real market right now for bridging at all, because it's just too much of a mess. And we've all been too focused on trying to compete. So I think the way that we'll get out of this and actually grow the pie and like get to the next step is going to be for us to all find ways to collaborate, and select, and of course like compete with each other as well, but like selectively compete. So like find ways where things like this, like these kinds of shared standards we can use that can push the space forward, and can like help more people feel comfortable bridging their tokens in the first place. Because like right now, there's only a small number of projects that even feel comfortable doing it because it's such a mess. To help this like push that space forward, while also providing structure for us to all compete with each other in a way that makes more sense. That's my hope, is like I'm really hoping that like the depths of the bear market are the time where we'll be able to finally come up with some sort of interchain coalition that is able to independently, like as a large group of organizations are able to collaborate to like build some of these standards, and provide structure to like an outcome to create an outcome which is actually really good for users.
Maybe I can just highlight some of the things we're working on at Hyperlane, which are kind of I guess, relevant to this discussion. So yeah, at the beginning of the call, I mentioned we're focused a lot on kind of this modular interoperability interface of allowing applications to specify their own security preferences. And I think that's really aligned with the ethos of the xERC20 standard of basically giving the applications back their sovereignty over, how their assets are issued and used across chains. I do think, I guess maybe as a call to action for people here, I do think there are like there's two I guess product experiences here. So one is the actual experience of like, hey, what does it look like to use one of these bridges? And what is the bridging, UX? And I think people have been competing on that for a while. But standards like these, like xERC20 or some of what Hyperlane's doing with what we call like interchain security modules, are really compete on developer experience. And so for projects in the space or on the call who are looking to actually take on the task of going multi-chain, and like Arjun said, like pursuing the next generation of the internet, I think you have to kind of embrace these discussions and conversations and play around with the standards and the tooling that's provided by these teams, rather than just like kind of being willing to accept some like out of the box service, which is maybe slightly more opaque and requires like less developer lift in the short term, but long term will cause a lot more kind of like product and user experience headaches. So yeah, just have to be kind of a little bit proactive with some of these things and engage on the forums and calls like this. And yeah, I love the idea of kind of having a continued collaboration forum for teams who are thinking about these problems.
Yeah, so I mean, I think there's two things. One is, of course, if this is an interesting discussion, definitely get involved in cross-chain stuff. We need more people to learn about how this infrastructure works, to learn about the trade-off spaces that exist in like a legitimate way, and not just sort of like just read like marketing material put out by projects. And if you don't know where to start, hit me up or join the Connext community, and we can like point you to helpful resources. And then secondly, I think, and this is the main call to action, I think we're in a really critical place right now with tokens. We're like people, this is like, the fact that the multi-chain hack happened recently is like has like spurred a lot of projects to start thinking about this problem. And I think that this is like the first time in a very long time that it's felt possible to actually have adoption of a shared standard like this. And if we do successfully manage to get people to adopt a shared standard, I think that would actually, into the long term, would solve so many problems for the space, and I think a lot of people in the future would look back and be like, it would just thank everybody in the past that actually made this happen. And so if you are a token issuer, so like a project that is thinking about issuing a token or has a token and wants to bridge to other chains, or if you know any projects that are in that position, please get in touch with us. Please like reach out, talk to us, talk to Hyperlane, talk to other projects that are interested in supporting the standard, because we want to work with you to make sure that this stuff is done right.
Amazing. And just about on time. We will, I guess, close up. Thank you guys for coming on. And thank you, everybody, for joining.